And now starting the webinar.
Welcome, everyone. The Emerging Technology Speaker Series is now back with this new installment, Automating and Innovating Agriculture. We're so glad that you're able to join us today. For your information, the webinar will be recorded. I'm Marianne Fantetti with Invest Windsor-Essex, and I'm here with my colleagues from our Business Retention and Expansion team, Wendy Stark, Yash Pagadella, and Francisco Contreras. This speaker series has been ongoing for a few years, and the purpose of it was to continue the conversation and act as a preamble to our annual Emerging Technologies and Automation Conference and Trade Show. By the way, our conference this year is on November the 2nd at Caesars. If you wish for more information, please visit emergingtechnologies.ca, and you'll get information there regarding registration and if you wish to be an exhibitor. Today, we are so pleased to partner with OGVG, the Ontario Greenhouse Vegetable Growers, the NRC IRAP, the National Research Council, and Automate Canada. Erin Coristine, who is with Ontario Greenhouse Vegetable Growers, will assist with the intro to the presentations, and Nicola Dimitrov will, from IRAP, will moderate the Q&A after each presentation. We are in for some very interesting and exciting presentations today from some very innovating companies. So you'll be learning much more about how technologies developed by the automation cluster in this region and just beyond can help make the agriculture industry more efficient, productive, and profitable. So Erin, over to you, Erin. Erin Coristine is the Manager of Science, Regulatory Affairs, and Government Relations. He obtained his undergraduate and graduate education in Waterloo with a research focus on microbial biochemistry and applications for novel therapeutic combinations that reduce occurrence of antibiotic resistance. He has since spent the last 5 years in both research and not-for-profit areas, spending the past few years with OGVG as the Manager of Science, Government Relations, and Regulatory Affairs. And Nicola Dimitrov is the Industrial Technology Advisor with the Government of Canada's Industrial Research Assistance Program. And Nicola has over 29 years of automation industry experience with an extremely strong comprehension of engineering, software development, and machine vision. He comes with an extensive background in automation technology, working for OEMs such as Ford and Tier 1 suppliers. He was one of the original owners of Radex Incorporated as Vice President of Engineering and Sales prior to his last position as Senior Vice President at AIS Technologies Group. Nicola holds an honors bachelor degree in computer engineering, and as I said, he's just recently joined IRAP, and we're delighted to have both he and Erin join us today. So over to you, Erin, for our introduction to the content of the webinar.
Good morning, everybody. Thank you, Marion, for those kind remarks. And without further ado, I'd like to introduce our first presenter, Mr. Brian Hendel. Brian is a locally born tech entrepreneur and is president of Splice Digital, a Windsor headquartered business software solutions company. He is also the co-founder of IPM Scout Tech, a globally recognized greenhouse IPM pest management software platform. Brian will talk about trends in artificial intelligence in the ag space and how recent advances are helping transform how growers are growing. We will look at where the AI and agriculture industry is now and get some insight as to where it's headed. So without further ado, Brian, thank you for being with us today, and I'm happy to pass over the stage to you.
Excellent, Erin. Thank you very much. Good morning, everyone. It's really great to be here today. As Erin said, my name is Brian Hendel. I am both the president of Splice Digital and a co-founder of IPM Scout Tech, which is essentially a startup from the main company. I've been in software for a long time, really since grade school. So this is my space, and I've been involved in software in the agricultural industry for about 3 to 4 years now. So really happy to be talking about AI in ag today. I think it's not hyperbole when I say AI is currently changing everything in so many different verticals. So it's a really, really exciting space. And I want to do something a little bit different today with this talk. I have one slide, and then I'm going to abandon my slide deck, and I just want to go practical, jump into a browser, and just make it a little more light, high-level, practical, and not going to be really driven by slides. So we're going to discuss the importance of AI in agriculture, some of the current applications, where we're going with AI right now, and then there's some time for Q&A. So anybody has any questions, I would be happy to answer. So let's see how this works here. So I'm just gonna fire through a few videos. So so what is AI, or rather, what isn't AI? So back in my day, really shows my age. We programmed declaratively, right? We did a lot of if this, then that, and we told the computer exactly what we wanted it to do under certain circumstances. So this is pretty typical, and how most of the software these days are written. And what do we mean when we say AI? So certain things humans do exceptionally better than traditional computers. We think abstractly, we're creative, we do pattern matching. So computer scientists decades ago actually said, why don't we try to build computers like human brains? So using artificial neural networks instead of the squishy meat ones that we all have. And out of that has come some pretty amazing stuff. So probably some of you have heard of Mid-Journey and Stable Diffusion. This is AI generated art, truly novel creations from an AI system. So this is crazy from someone like me who's used to a lot of traditional if this then that type programming. We never expected creativity to be emerging from AI so early. So well, what does this mean for ag? Like, this is pretty pictures, that's fine. What does this actually mean for the agricultural industry? So AI is a huge term, and it's touching almost every sector right now. And in the greenhouse specifically, you've got AI interacting with robotics, self-driving equipment. We see this here locally at some of the bigger growers out in Leamington, automated pickers. So things you're seeing in this video, right? But the things that I personally find most exciting are the opportunities and more of the thinking activities. So these are the things that are less robotics and more happening in the grower's brain. So I've been told there's some growers in the room. So you would know, obviously, that running an operation in a greenhouse or in a field takes a lot of thinking activities or expert activities. These involve things like planning and yield prediction, pest and disease diagnosis, and grower decisions like optimizing fertigation and lighting. And there are initiatives underway right now to augment these experts in almost every one of these areas. In many cases to empower them, in some cases actually to replace certain human processes within the facilities. But so there's a lot of exciting things happening. But really I want to talk about some practical examples of AI around the more thinking activities here. So so this is fun if this is going to work here. So so some of you probably have heard ChatGPT. It is what's called a large language model. So basically, in rough sense, this means we have a virtual brain that has been trained around a huge amount of text, research papers, articles. But I just discovered, did you know it was also an amateur grower? So let's see if we can pose it a question here. So I just wrote up a question. So, pretend you are a professional grower growing cucumbers for an industrial greenhouse. Your cucumber is at the fruiting stage, and your scouts have indicated that there is a powdery mildew showing up on the leaves. What would you recommend? So I'm posing this artificial brain a question now. So, and again, this is not an agricultural product at all. This is just a brain, artificial brain that knows a lot of things. So you could see it's actually writing a response in real time. This is not for for special effect. This is actually the AI generating these words as it's outputting to the screen. So this is its response. What do we do? What would you recommend? Early detection, prune the infected leaves. We can optimize environmental conditions. So it tells you powdery mildew is thriving in warm, dry, humid environments. So obviously it knows something about how powdery mildew works. Biological control agents, which is something we involved with a lot in the software that we've built, fungicides. So this is some good information. Obviously, as a grower, if you're in the room, you're probably going to roll your eyes and say there's a lot more to it, which of course there is. This has just come out. Like this, the initial versions of ChatGPT have come out in late 2022. And this is not trained on anything specific in the greenhouse industry or in the agricultural industry. This is just broad information. What's even more interesting is I can actually then pose it further questions. Let me say, well, what fungicides would you recommend and how would I use them? So this is following along the line of reasoning that I've already started here. So it's making recommendations. It's actually giving me products to use. It's giving me, it's telling me how they work. And I repeat, this is not an agricultural product. So with AI, it's very important to look at where we are and then look at where we're going to be in the next few iterations and try to determine a path or a curve as to where we're headed, right? So already this is just the most generic tool that's available that's already could provide some value to growers. And I could see where this could head with more industry specific training. So it's still going here. So something more greenhouse specific. So this is just a picture from Hogendorn. So imagine something similar that we just saw, leveraged specifically for the agricultural industry. So essentially an expert system trained specifically on your data set. So we've been in talks with Hogendorn to just see what they're up to. And they're operating in this space. Already they have some AI technology in their products, but they're looking to essentially create an AI-powered grower assist platform. That's in the works. So that's taking all the various sensors within the facility, trying to integrate them into a virtual growing platform that can then assist the growers, empowering those growers to grow with a larger portfolio because they're doing less manual work out in the field. An example of a product company actually that we did work for out of Montreal a few years ago, Motorleaf. This is just one practical example. It's a little more related to the back office. So the growers in this room would know farms have a bit of a problem. They need to figure out what their yield is going to be, right? They've made commitments on contracts and they need to know what the output is going to be. So it's tough for them to do that, and they use their own gut instincts. So Motorleaf was one example of a product that took all the sensors within the facility, all the light information, the soil pH, fertigation, lots of historical data, and use AI to then predict yield, to give growers, to give their sales team the information necessary to make better informed decisions. This is actually honestly a lot harder than it looks. We were kind of boots on the ground there, and we realized just the amount of raw data, the huge amounts of historical data. Any faulty sensors in that facility give incredibly erroneous data into the model, and it's really, really a problem. So there's a lot of challenges, but this work is actually happening in the field. Another practical example, company that we've been in talks with as well, they're trying to install sensors, or rather cameras, all over the roof of greenhouses in order to watch the crops all day long. So imagine a grower who's looking at plants continuously and looking for signs of stress, pest detection, bud detection, if they're in cannabis, looking at where the buds are starting to exist in the field. However, again, these types of solutions get very expensive. You have a lot of money invested in camera systems and a lot of processing power churning through huge amounts of data. We're talking hundreds of gigabytes a day. You have to then have servers on the farm because you can't move that kind of data off premises through, the internet connection of a lot of these facilities. So let's look at how AI is changing existing products. And I'm going to use an example of our product here, actually. So I'm the co-founder of IPM Scout Tech. So we built a crop health management platform for greenhouses, helping these facilities track their pests and diseases. And we've built an app to help scouts out in the field uptake their information. And of course, what you see here are tools for the growers to help determine courses of action and increase yield and reduce crop loss and really help them make better decisions. But what do we do with AI now in this industry? So we are currently in the process of helping to detect pests automatically. So instead of having to count pests manually on sticky cards, we're working with technology that can help identify what those pests are and how many, so that they can make better informed decisions to help fight those pests out in the field. Also, tools to assist growers to take preventative action. So what biologicals to release out in the field and when, at a point that would optimize for economic injury within the facility. So how can we make a small amount of spend to prevent a large amount of spend in the long run? Also, how do we stay in compliance, which sprays and beneficials make sense together? I mean, it's a whole industry in and of itself, and AI is starting to really play a large role here. And for most facilities, take a cucumber facility local to us here, input costs could range anywhere from 15 to 20%, and labor costs maybe 30%. So if a product like ours, through AI and through traditional solutions, can help reduce some of that cost, obviously that's an enormous impact to their bottom line. And again, we're not replacing the growers in this process. And in fact, we're not even replacing the scouts. We're empowering and augmenting these individuals. So, and I'll be honest, I've been in software for over 20 years. I've seen innovations happening all the time, but I've never seen a single major change or innovation in my field that seems like it is changing every vertical in a brand new way that has a huge potential to change the fundamentals, right? So give you some context about ChatGPT as an example. It's still in beta. Like what you saw there is not even officially released, right? So it's writing poems. I use it to create Christmas poems for my family last year, and it was tons of fun. It's gone from version 3 to 4 in 6 months, and during that time, cognition has gone off the chart. It went from passing the bar exam at the lower 10% to the upper 90%. Think about that for a second. This is just asking this generic knowledge base. Again, it's not an ag product, it's not a legal product, it's a generic artificial brain, able to pass very difficult human tests better than most people. That's mind-blowing. Now it's able to accept images. So you could say, hey, I have a plumbing issue. Here's my plumbing. Can you make some recommendations specific to me? Try to imagine visualizing that out into the agricultural space. So again, just examples of where things are going, not that product is going to specifically be used there, right? So other than the robotics and the traditional picking and things that have been going on incrementally for a while, I see AI really taking over in the expert systems space, kind of like a doctor visit, right? My crops are at this stage, they have these symptoms. Here is the fertigation, the soil composition. Here are some pictures of what I'm dealing with. What do I do? And then proaction. So we're seeing a lot of AI systems coming up that are ingesting sensor information, saying, oh, I think you're going to see a problem in a few days. You might want to put out some extra biologicals or correct the soil. These are feeding growers actions that the growers would not have normally got to at that pace, right? Or at all. So just imagine the improvements to yield, the reduction in pests and disease damage. Huge opportunities here. But it's also scary, right? This worries me on a number of dimensions, and you can't talk about AI without talking about risks, because actually even the company that built ChatGPT, OpenAI, is holding back. They're saying we're kind of scared where things are headed. We've got things we could do to this, but we're actually going to slow things down because people are starting to get worried. We actually are using ChatGPT to write code internally. Can you write code to do this? Boom, 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 boom. Code comes out. It's mind blowing. But there's notions, they call them hallucinations within AI, where it says something completely and utterly false. Like it was actually told somebody that Elon Musk died in a car crash in 2018. And I mean, who knows? Maybe he did, and he's been replaced by some AI or something, and that's why he's acting so weird lately. I don't know. But probably, there's a certain trust factor that has to be managed here with AI, where it is right now. But again, always be thinking iterations forward. And we're not even talking decades. We're probably not even talking years. We're talking months, the amount of research papers that are coming out in this field. So again, this was high level. Talked about a few products, talked about some concept, some concepts, but I hope something I said here was stimulating and informative, and gives you an idea of where things are headed, because it's not just ag. This industry is changing everything in a very fast pace. So that's all I've got. If there are any growers in the room who are interested in talking about IPM Scout Tech, feel free to reach out to me. Other than that, I am happy to take any questions or prophetic statements about the future or anything like that.
Well, thank you, Brian. I really enjoyed the format of your presentation. Certainly, we have done lots of things with AI so far, but I truly believe we just scratched the surface, and many other applications are yet to come. The podium is open for questions. But I'll take advantage of my position and maybe start with the first question, Brian. What do you think the growers can do today to prepare themselves for adopting this new technology?
Yeah, that's a great question. It's been asked of us before. So what we recommend and what we see some of the growers already doing is collecting everything. Collecting data, storing in what's called a data warehouse or a data lake, and cold storaging data for future use and analysis. So you're collecting, most greenhouses, most agricultural facilities have large amounts of data, soil composition, plant growth, radiation or lighting, and don't lose that, store it. And I think it's going to become hugely important in the future. So that's, I think, I don't want to say an easy thing they can do, but a relatively simple thing they can do.
Yeah, that's a really good answer. That is the reason why AI is so capable, because it was trained on all the data that was available on the internet anyway. Thank you very much for that answer. I'm just waiting for some questions from the audience. If not, I have a couple more for you, Brian. While we are waiting, I hope there are some business owners as part of the listeners, and ROI is always a big question when you're doing a business investment. So what do you think, how can you measure ROI when you're applying AI project?
Yeah, that's another good one. Many of these products have a cost, and it's not an insignificant cost. So normally when we're discussing value proposition, it's a matter of what's the outcome. Obviously, are we reducing human labor? Are we increasing yield? what does the short term versus the long term look like? Is there an investment in cameras that then need many years of payoff? So I think looking at that strategically, like you would any other capital investment, trying to really wrap your head around the value proposition. What are the risks? The thing with AI is it's non-deterministic, which means in one facility you could have 90% accuracy, and pest detection in another facility you might have 80. And why is that? You have all kinds of factors, really, but you can't really guarantee performance. So you can make a large upfront investment and still not achieve the results you were promised. So do you have a way out? Do you have an exit, an off ramp of that product if it's not achieving for you? So looking at the whole picture like that, I think is incredibly important.
Aaron, do you have a question?
Yeah, I do. Brian, it's some really fantastic information and insight there. I think, there's an opportunity, and if you could speak to this, we hear more and more about farm ownership and the next generation of, succession planning. So would you say that perhaps there's opportunity for this AI to prove as a strategic consultant for younger farmers to understand and adopt on-farm practices to be more efficient and dynamic more quickly?
Yeah, that's a really interesting idea, especially if you take into account that could be a hybrid solution. So the case of Fermata, if the system fails to be able to make a determination of what to do, it actually brings a human on sort of transparently to the platform. So given that it doesn't have to be AI or nothing, if someone were to build a virtual consultant platform or an expert system, as we call it, to be utilized for younger growers that need some external help, mixing that with really strong human growers into the mix to kind of round out, now you're not alone, right? Now as a grower, you look at something and saying, I don't know what's going on. I don't have the resources on hand to know what's going on. I have some consultants in my bag, but a lot of them are tied to providers, like beneficial providers. Well, are they motivated to make the right decision or to make a cost profit decision for themselves, right? So having a platform that mixes AI with human that you can consult into, you can feed it imagery and your historical data, could be enormous, and also allows those individuals to abstract slightly away from the actual facility as well. I'm seeing more and more sort of strategic office setups where they have their growers who are managing facilities all over the world, and they're looking at their various panes of glass and centralizing their growing team in one location, but growing internationally. We're seeing a trend there, and I think AI is only going to help the transition slightly away from out in the field, but for better or for worse, probably for the consolidation of the industry as well. People that are growing really, really well in a back office in the Netherlands are going to have an easier time consolidating the industry. Whether that's a good thing or a bad thing, I'm not going to say, but AI is only going to help that along.
Excellent. I appreciate that insight. And just a quick follow-up before we move along is that we see, specifically from the greenhouse sector, farms varying in complexity. Some are early adopters, some are adopting as they go, and there's certainly financial constraints there. So one thing that has been identified is that all of this data that is stored on farm sometimes is siloed throughout the operation. It's not aggregated in easily accessible locations. So is this another area that AI could help level the playing field for farms that have that gradient in advancement?
Interesting. I mean, like I said, some of these products require a large upfront commitment, and you have to look at how that scales. Some of them, like ours, scales to the size of your greenhouse. If you have half the size of a greenhouse, you're paying for half of a license fee. So some of these products do scale. Can AI help with sort of the fragmentation of data throughout? I'm not sure. I think at that point, you still need humans to be able to help pull that data together and say, okay, let's break down these silos. Let's pull data from these various sensors. You got a growing system and a climate control system and fertigation system here. Let's just step one, hire a consultancy, pull that data into a single place. And there's a very, very large facility out in Leamington that's doing a lot of that. They don't know what they're going to do with it, but they know they need to capture it, and there's no reason why a smaller facility can't do it. The costs don't scale as well. I don't know if AI is going to solve that cost problem yet for the data aggregation.
Excellent. I don't see any more questions, but I will ask you one more before we let you go. How close or how far are we from general AI?
It's the big question. I mean, you've heard everything from people saying they've seen sparks of it already, people that disagree. So I can't answer that question. I'm not qualified. Though I can say there are enough serious players like Wozniak from Apple who are saying, whoa, Elon Musk, I think even Bill Gates, saying we're like getting there. And the problem is it's called the singularity. You reach a point at which it's a recursive process where the AI is smart enough to make better AI. Once that happens, you go vertical, and it happens very, very quickly. So you begin to increment, and you're like, oh, well, having a generalized AI is way off. Well, it's only as far off as you need to get a recursive self-improvement process going. As soon as you're there, the AI can make itself way better than it is, and that happens very, very quickly. So we have to watch. We are incrementing. We see a pace of iteration, a pace of increment. There's a gear shift that happens, or that's proposed is going to happen. That's going to go from really good to superhuman in record time. That will violate what that curve would look like. That's why nobody really knows. We don't know. All I do know is AI is writing code for us, and I can give our code to AI, and I can say, what's wrong with this code? Make it better, and it can actually do that. So we're actually holding back right now. The OpenAI, GPT is actually holding back and not doing some of these things because they're kind of afraid.
Thank you very much for your answers, Brian.
Yeah, thank you.
Aaron?
Thanks, Brian. Next up, we would like to introduce the team from Innovation Technologies. First is Leslie Pillon, who is the Vice President of Innovation located in Stony Point, Ontario. Leslie's worked in automation for more than 30 years, with 22 at Innovation, and prior to that, 10 at Magna and Windsor. Leslie's biggest strength is problem solving, which is also a prerequisite for innovation. Leslie is also a graduate of St. Clair College. Trevor Johnson is president at Innovation Technologies, holding diplomas in both electronics technology and industrial controls. Trevor is also a local soybean farmer. And lastly, Dennis Marchand, who's a mechanical designer for Innovation Technologies, working on all types of machines for both design and build. Dennis also enjoys all types of R&D challenges. Dennis also holds a Canada-wide tool and die certificate. So without further ado, the team from Innovation, thank you for being here, and we're very excited to see what you have for us.
Thanks very much, everyone, for joining the webinar. Special thanks to Invest Windsor-Essex for providing a venue for us to showcase our innovations. Special thanks also to IRAP for being a partner in our prototyping and development activities. We certainly couldn't do the things that we're going to show you today without your assistance, so we appreciate that very much. Big welcome to the Ontario Greenhouse Growers Association, and also the all the growers that have joined the webinar today. We really are honored to be here today to show you some of our recent work. I have with me today Trevor Johnson, and also Dennis Marchand. Myself and Trevor started Innovation in 2000. We came from the automotive environment, and both of us were basically felt unchallenged in that environment. So we decided to start our own business where we could work longer hours for less pay. But anyway, we really enjoy what we do. And we have a team here that has done so many great things over the years, and it's incredible when I look back and see the size of projects and scope of projects that we've been able to accomplish with a team. We have a team here of approximately 16 people, but we act occasionally as a company of double or triple that based on our efficiencies and the way that our guys step up to the plate when needed to get the jobs done. It's going to step forward here. So for 22 years, Innovation has been an innovator in custom automated machinery primarily for the automotive industry. Trevor and I, when we started Innovation, we had desires to become a product manufacturer. We did not intend on entering the automotive sector. We were planning on developing, and prototyping our own products as a primary business function. But as many of you know, when you enter the automotive realm, it kind of encapsulates your entire activity, and we're no different. And so our product innovation has sort of taken initially took a back seat to our legacy business. And in 2018, approximately, we made a commitment as a company to allocate more of our resources to innovation. And basically, that's when IRAP came on board with us, and we started developing our first project with IRAP. And so what I'd like to do, just before we get into the greenhouse innovative products that we're showcasing, I wanted to show you guys a couple recent projects that we've been working on, just to give you an idea of what Innovation's capabilities are. So the first slide here is a product that we developed within the last 6 years, and it's basically a verification cell. And what it does is it allows you to verify the CAD dimensions of virtually any part instantly by scanning across it and comparing the scan results to the CAD model. Basically, we can scan any automotive part that'll fit in the machine, aircraft parts, engine parts, medications in pill form. The advantages of this machine is that it runs on a standard 120 volt outlet. It can be plugged and moved virtually anywhere in the plant, and the tooling can be changed. So the fixture you see here can be changed instantly to run different parts. And as the fixture is installed in the machine, it automatically recognizes which part it is through use of an RF tag, and the machine self-configures to that new part. So essentially, we can, if you can imagine a plastic injection facility during the startup on a Sunday, for example, where they have to do first offs on the parts, CMM checks take a long time. So this machine can literally do first offs on all your parts within minutes. So it's a very cost savings and time savings type of product. This is an example of a scan. So here we have a fixture. We're scanning across it, and within seconds we'll have a 3D rendering of that part, which we can pick certain key points on the part, and we can compare it to the CAD data and either pass or fail on those data points. Another recent machine that we built is this machine here. This gives you an idea of our capability here at Innovation. This is a robotic brass insert cell, and it installs brass inserts by heat staking into valve covers. And so all this machinery is built here in our Stony Point location. We have a robotic brass insert station and also an inspection station. 2 robots are used in tandem to install the brass inserts, and then one station also does the inspection of the inserts. We have to make sure the inserts are not inserted too deeply into the valve cover, and also, you know, fully inserted flush, not too deep and not too tall. Inspection station uses an LVDT to check the heights of the part. This is a video here. We've got 2 robots picking from a feeder and automatically installing the brass bushings into the valve cover. So as I mentioned earlier, in 2018, we began working with IRAP, OGVG, and Automate Canada to assist the greenhouse growers in preparing and evaluating feasibility of automation solutions provided by Canadian automation solution providers. Since this time, Innovation has worked on 3 major projects for the greenhouse industry. And so I'm going to showcase those 3 today. All these solutions are, by the way, are patent pending. So I, particularly on the automatic stringing, I won't be able to show you the entire device at this point, but we can show you it in operation actually tying knots. The first machine I want to show you guys is a solution for sorting vine tomatoes with singles. And as you guys know, it's very important to match exact weight of shipped tomatoes. In this example, it could be cucumbers as well. When we're shipping, product to the customer, for example, if we're shipping 1 kilogram of product, we don't want to give them 1.1 kilograms, and we certainly don't want to give them 0.99 kilograms either, or because we're going to get stung. The customer, the customer is going to penalize us for being underweight. And we don't want to give them overweight either, because that's coming out of our pocket. So this machine here is a solution, a robotic solution, to basically marry single tomatoes with vine tomatoes. So we have a dual input conveyor system here, where singles are installed in the trays, and this is a circular conveyor that goes in a loop. And inside the cell, we have 2 cobot robots that are picking singles, and as it picks, it weighs the single tomato and stores the weight in the PLC. And then it's placed into a storage location where later it can be retrieved and married with the vine packages. So on the grippers of the robots, we have a load cell to measure the weight of every single. The operator on the exit side places an empty tray with a vine on the scale, and the robot will pick the exact single or singles to make sure that the weight of the package equals our desired weight. There's a shot of the load cell and a special gripper. Here's a video of the actual gripper that we developed. And as you can see here, we have no problem at all grabbing the tomato. We can pick it up, we can set it down. We're not damaging the flesh. So overall, operator 1, and this can operate with as little as 1 operator, depending on how fast you want the throughput to be. But in this case here, we have 2 operators. So this operator has singles from the storage and loading singles onto the input side. These can be green or red, by the way. You can sort green or red or both. And you can use 1 lane or both lanes. You can choose. The machine is totally configurable. Vine stock is over here. So the operator grabs the vine stock, places on the scale. And then the robots automatically marry that package with the correct singles. So we have a control panel, human machine interface, the scale adjustments, panel located below with your controls and your PLC. Fork tube set, so the machine is portable. It can be moved basically anywhere you want. Scale for one for each side, so you can run with one operator on one side or two operators, depending on the throughput you desire. One other major feature of this machine, we have an overhead vision camera to monitor the contents of the trays, and that's important that we keep track of the fruit that's in the trays in case there was ever a mix-up. Basically, we want to make sure that if there's any misalignment of tomatoes in this case, that we detect that. We can also use the camera to detect the quality of the tomatoes as well and the ripeness. So underneath, we also have trays for cleanup. The trays come out, and there's actually holes in each storage location, drain holes, and so the machine can be completely disassembled and cleaned when desired. Advantages of this machine: require manpower for exact weight sorting and packaging of the vine tomato. System can operate with 2 or less operators. A third operator can be added in order to increase throughput for 2 colors. 100% sorting with no missort to rehandling. High reliability. Robots are performing the handling and the weighing of the scales, of the singles rather. Very few moving parts that require maintenance. Vision camera for constantly validates the tray contents for mislocation. Floor space system is footprint is very small. Multiple systems can be deployed. Flexible tooling can be changed over easily. This means the system can process different vegetables. For example, it could be changed over to process cucumbers. The next solution I want to talk about is lighting covers. We heard, and let me just say thank you for the growers for letting us into your farms to understand your businesses and understand how automation can assist you in your efficiencies and your cost effectiveness. We've learned a lot from you guys about different things that you require. One of those things that you told us was that bagging of the light fixtures for spraying operations was very labor intensive, and it takes a very long time, for example, to bag all the lights. Why do we bag the lights? Of course, because we don't want overspray to damage the lens on the lights. These lights are very expensive, and we don't want the surface or the lens to be contaminated at all. And so typically what's done is the lights are pre-bagged manually with plastic bags, and that you can imagine is very labor intensive. And so we came up with these light covers that swing in and out of place to cover the lights during the spraying operations. So it's a very simple device. It has a counterweight to hold it in either position, open or close. So this would be the closed position. That's the open position. The cover does not impact the hangers whatsoever. So advantages of the light covers: reduce risk of damaging the lens surface. Time to cover the lights is dramatically reduced. Permanent installation, no storage is required. Less waste material, nothing going to the landfill. Automatic operation. So we are working on a cover that can be open and closed as a bank of covers, for example, using Bluetooth. And we envision being able to open and close your covers in banks at a time using a smartphone app. So you don't have to, physically use a actuator to open and close the covers. With our actuators that we show today, they're manually open and close, but we envision that this could be done automatically. The third innovative solution that I want to talk about is automatic greenhouse stringing, and this is a project that we've been working on most recently with IRAP, and they've helped us out immensely with resources and also funding. What we learned from the growers when we visited multiple farms is that greenhouse stringing is also very labor intensive, and it takes a long time to tie these strings. And it's a fundamental aspect of greenhouses, having the strings for the vines to grow on. And so for that reason, we been working on an autonomous autonomous stringing system that can be used in the greenhouses that can work by itself autonomously, tying strings from one end of the aisle to the other without any intervention whatsoever. And we've received a lot of positive feedback on this product, and we're very excited to be on basically the third level of the prototyping. We started with a basic prototype, and we made a working fully automatic prototype, which I'm going to show you today, that's tying strings. And now we're on the phase of the autonomous aspect of it. And so we're very excited to get one of these units into the greenhouse and showcase it in working order. So this is a typical greenhouse here. You can see that the vine strings are hanging from the wire overhead, and we also have our steam heating pipe work on the floor here. Another shot here shows that the overhead support cable running along the length of the aisle on both sides. And here's the LED lights that I showed you earlier. Here's a video of our tying strings. This has been slowed down for video purposes and demonstration purposes. But here we show the support cable and our device to tie a knot. So in this case here, we're moving the wire instead of the device, but the device will obviously move along the aisle, and the distance between the tied strings and also the amount of the distance of the dispense string at the end, you see it when it unrolls, that's all totally configurable. I'll show you one more cycle here. Here's a number of strings that we tied during that video. And as I mentioned, the distance between the strings, the tied strings, and also the amount of dispensed string is all totally configurable. because as you can see, the system cuts off the string at the desired length. And we can configure that length to be any length we want. This is a close-up of the tied knot. It's a 1/2 inch slip knot. There was some question about what it was called, and we learned from the growers. That's what we call them. And basically, it's easy to untie it. You just pull the one side here, and the whole string comes down. So the advantages of the automatic stringing, obviously, the system can operate with or without an operator. Basically, the only thing the operator has to do in the beginning is start the system on the aisle, and the system will complete the tying on both sides of the aisle automatically. It's very, the working conditions up tying strings are very, very difficult. It's very hot. The workers can only work a certain amount of time and tie so many strings before they have to take a break. The machine will tie knots more reliably. The strings will always be the same distance apart, and they'll always be the same length. And as I mentioned, the length and string of the spacing between the strings is fully configurable. Dennis, do you want to comment on the string and the special research we've been doing on the string for manual tying versus automatic tying?
Yes. What we found is that the existing string has been meant for hand tying. We've talked to a couple of string companies, and they can make the string more adaptable for machine tying. Actually, what the string manufacturers do is they soften the string for hand tying, and that's we find that the string has irregularities in it. In other words, when you're pulling string out of the roll, you can get a normal string with a normal twist, but then every so often you get a section of string that basically flattens out like a ribbon. So that, what we found, creates some consistency to the string. So we have talked to one company, and they're interested in helping. And what we're going to do is go see them tomorrow, and we're going to discuss how they can make the string more machine friendly, because this string is meant for hand tying.
Thank you, Dan.
We're also planning to go see Conrad tomorrow, and perhaps we can see if we can put this machine on his lifting machine.
Yes, thank you, Dennis, for mentioning that. We may work with Conrad, that was the next presenter. He has a very nice unit that he developed for already traveling down the aisles, and so we're going to entertain that possibility. So I'm sure that you guys are going to like his presentation, which is coming up next. So that's the end of our presentation, and again, we thank you very much for giving us the time to showcase these innovative ideas.
Thank you, Leslie. Trevor, really excited to see the versatility of your capabilities, Leslie. Over the years, you guys have developed an excellent company, going from using induction heat to put the inserts into the valve covers, all the way to stringing vine strings. It's amazing. Thank you again for the presentation. I'm opening the podium for questions. Okay, while we're waiting for questions, Leslie, I do have a couple of questions regarding the tomato sorting machine. Is the vision system doing any vision guided robotics, or just doing quality control?
So that's a great question. The vision camera actually does take regular pictures of the trays and actually does guide the robot to the trays. And so we're constantly monitoring the trays. For example, if the tomato was to move in the tray, every time we perform a pick operation, we're going to take a picture, and we're going to make sure that we're perfectly centered on that tomato before we grab it.
Okay, thank you for the answer. Another question I have, it's related to, the end of arm tooling. Like, what consideration were taken when you were designing the tool not to damage the skin of the tomato and reduce the shelf life?
So we worked with a company in Boston, Massachusetts, to develop this gripper, and it's a special gripper, and obviously it's a balance force type of gripper. So it basically takes the shape of the fruit as it grabs it, and it produces provides uniform force around the outside perimeter of the fruit. So there is no pressure points whatsoever. So we worked in conjunction with this vendor to develop this gripper.
Excellent. Yeah, so you were taking a scientific approach to the design of the end effector. That's great to hear.
Yes. Dennis, do you have anything else to offer on that?
Yeah, this gripper is also capable of conforming to things like peppers and cucumbers and other types of vegetables or fruits. It is brand new, so
Excellent.
so that's it.
Aaron, do you have any questions from your end?
Yeah, I do actually. I've got a couple. Again, another brilliant presentation here with some meaningful information. I'm wondering on the tomato gripper, and I think it was just addressed, so it can go and be functional with various commodities. But I was wondering how, if the next iterations or studies would include specialty tomatoes, smaller tomato types like grape and cocktail, as well as what type of alignment could this gripper have with farms that are currently deploying automated processes through automated graders.
So when you're mentioning grading equipment, you're talking about using cameras to detect the grade of the fruit.
Yeah.
And that's exactly that aligns with Nick's first question about the camera, and I mentioned it briefly in my discussion. Not only are we using the camera for guiding the robot, we can actually use those cameras inside that robotic cell to grade the fruit as well, from color to shape and size, as you mentioned. It's very flexible when you have a vision camera of that capability. And Nick I know knows a lot about vision, so but and so do we. I mean, we've done a lot of vision applications over the years in the automotive space. Vision is an integral part of automation now, and so
absolutely, yeah.
Yeah, and then my second question pertains to the string time, and that have you given any consideration, or is it maybe further down the line, as to biodegradable and compostable strings, and if that would have any impact, the material type on the ability of the machine to tie, or do you not foresee challenges?
I believe that the string is already biodegradable. Dennis, can you comment? Can you answer that question? I think that that's true, right?
Yes, I was told the string was biodegradable, and basically, when we talked to the string company, is that what they're going to do at first is just modify their string, and they're actually going to do less processing to it, and to make the string more capable of being run through a machine. Also, these typical string rolls have an inside diameter. The string always comes out from the inside, and the inside diameter is usually around 1.5 inches or 30 millimeters. And taking string out of the center of those rolls, you end up basically taking out a spring. So the spring is a little more difficult to handle with the machine, but we also talked with them about starting the inside of the roll at a bigger diameter, which now makes the string straighter and more consistent. Because in the string in the center of the roll of a normal roll, when it comes out, it basically looks like saw blade. So it's more difficult to handle a string in that condition.
And our intention is certainly to develop with the string manufacturers the perfect string for the automatic stringing system, because we don't need to have a string that's designed for manual tying. If our intention is to install all future strings automatically, then we can custom design our string for our purpose.
That's great. I do have one more question regarding the stringing application. Are you planning to implement a vision system to detect if the knot has been created properly?
Yes, that's a great idea. And thank you for that question. Right now we have a camera planned for the unit to detect the location of the cable on an ongoing basis while we're tying, but we hadn't not planned to check if the string at the end, but that's certainly, we can use the same camera to do that, and we certainly will do that. We will verify that the knot's been tied successfully. And I mean, it could be any range of actions taken after we detected unsuccessful tie, and that would aid in the robustness of the equipment.
Yeah, excellent, great idea. Aaron, any more questions? Anybody from the audience before we go to the third presenter?
No, I think that those were some very, very excellent insights they were able to provide us. And if there aren't any further questions, then thank you to the team at Innovation for the information you provided. And for those in attendance, please do reach out and connect with them for further information. But I would like to introduce the final presentation and presenter on the day today to round out some of these discussions, and it's Mr. Conrad Connor. Conrad is the founder and president of Connexio Inc., a London-based custom automation and robotics company celebrating their 20-year anniversary this year. Conrad also serves as the chair of the board at Tech Alliance, a London-based regional innovation center supporting and fostering startups and scaling technology companies. Conrad, thanks for being with us, and I hope everyone's as excited as I am to see what you have for us today.
Thank you very much, Aaron. Thank you, everybody, for being here, to Windsor Invest and to the previous speakers. It was very interesting to see your presentations. We, of course, know both innovation and IPM Scouting very well. We've been actually had talks with them, and we hope to work with them together. And that will be pretty much the tone of my presentation today, to kind of show you how we think we want to tie these different technologies in together, and that we actually need to work as a community, together on these things, because the tasks in a greenhouse are really vast, and there's a lot of application need to be done. And I don't think one company or one technology alone can solve all these different requirements that are coming up. And with working together, I think we can get there quicker and can get there much more successfully. So I'm going to share my presentation here today. So it's all about greenhouse automation, obviously, and I want to show you how robotic rover and application platform would be used in high wire greenhouse automation. So while I'm going through this, I want to show you a little bit the justification why I think we can provide some input, some valuable input to the agricultural or greenhouse automation side of it. But I'm going to take you a little bit through our history to show you how this all came about, that we reached that part. And then what is our vision basically from here? Where do we think we want to go as a company and as an industry? We basically started not unlike innovation in the custom automation field. Like we heard, we've been 20 years in business now. I myself been in the automation industry since the late 80s, actually, hence my gray hair. But I came over from Germany at the time, and I started a facility, a North American facility for a German machine builder that ended up not staying in Canada. They ended up closing the operation, but I did stay. And so I started my own business in 2003, building custom automation. But from the very beginning, we always had kind of a need, or saw a need, to change the automation industry somewhat. Automation, as you know, especially in the automotive or in the auto products manufacturing, these are very much dedicated machine to one specific product. And what happens here, they are very much custom engineered. So basically, you design the specific machine for one specific product for one specific customer, which of course is very hard to do. Every project is different, every application, every requirement is different. Some customers want rather something cheap and dirty. Some customers really pay attention onto a lot of high-end input that has to be in there. So all different requirements, and sometimes it's a machine build, it's very hard to fulfill all those things. Let alone, of course, when it comes towards the end, all the programming and all the items to make this machine actually work, where it becomes more difficult to try and get all the programming without any bugs working. Well, never really without completely any bugs, but at least to a good working method within an acceptable range that we actually can ship it. So with all these, with one-off kind of scenarios that we initially kind of had to work with, from the very beginning, we always thought there must be a better way. And we thought about a platform. We thought about how could automation be more platform-based and be more of a system that actually is where our goal is, or our dream is, or actually we're almost there, where the machine is 70 or 80% is standard systems. It's pre-engineered. It has already a PLC and a programming already built in. So we have already pre-built those things. We tested them. We did life cycle testing, and now we know exactly what's coming out of it. And we don't. And the ambiguity of a custom-built machine is pretty much gone away now, and we can rely on a much better output and performance. So our systems, as you see here, they're vastly different the way they look now. The cells are all very much look alike. The internal, the tooling is all different. Obviously, they all do a different thing. They all do, every cell has a different kind of a requirement. It's all tooled differently, but yet the heart of the system is all very much alike. And we actually managed to achieve that through a platform automation side. So we liked that industry. It was nice, but then at some point in time, we stumbled upon a partner of ours. They wanted to do the mushroom harvesting. So they said, well, could we not automate the mushroom harvesting? And I cannot show you many pictures in there that are proprietary, but we helped them on developing the first robotic system from the same kind of idea. What is our experience level? How can we pre-engineer something and pre-build something that can then afterwards being adapted to specific application? And so we liked that industry. We thought that's kind of nice. We, again, didn't start that. A partner of ours came to us, but then we took it from there. And thanks to IRAP and their great support in many different ways, actually, they helped us both. They posted projects to us and said, hey, could you guys do this? Could you guys do this? But also helped us and support financing some of them. So IRAP has been a great source for us in many different aspects as a business partner. And then we started thinking about greenhouse robotics. So we thought, okay, well, how could this actually look like if we try to come more from the platform approach? So rather than custom building everything individually, our dream always was more like to build a platform for robotics that actually can be used for many different applications, not just for one specific one. And here you see a few pictures. Obviously, these were the very first early stages, and they were kind of interesting, but there was all helter-skelter, and it was all kind of just get it work. see what we can do, see what we need to learn from it, see what we actually have to iterate and make it better, basically. But it was for us always very, very important to get very quickly into the greenhouse and try things very early, because at the end of the day, we are actually engineers and not farmers or growers. So for us, it's very difficult sometimes to understand why growers do things in a certain way. So we had to learn all these things, and we wanted to do this as quickly as possible, not trying to develop a product that we thought it should be, and then get to the greenhouse and then they say, yeah, that's not going to work because of this and these applications. So very early we went to the greenhouse. We made sure that our track system worked. We made sure that our rover could drive. We made sure that the operator could handle it and could move it around. So all these things we've done, and we kind of started with a simple process, started a minimum viable product early on to test these things out. And then we kind of planned in development cycles. So now we wanted to always kind of get better and get better and get better and do more. And one other things we saw from the very early on is that we wanted to develop partnerships. We don't believe that we can do it all of our own, nor do we want to. But it was always very important for us from the very early stage to actually develop partners who can bring specific agricultural greenhouse automation knowledge to it, that we can actually partner with them and build with them together. So we kind of thought a little bit, where's our strength? Why do we want to enter this industry? Why do we want to get in there? And for us, it was clear that we are very good when it comes to motion, when it comes to robotics, when it comes to handling of certain components, and the whole material flow and everything. I mean, material has to flow as well in the greenhouse. You have to get the products from the harvesting to the packing. You have to make sure you handle all these different applications. So we knew we can do these things. That was what we're good in. What we're not really good in is that we're not really horticultural experts. We don't know much about these. We're not agronomists. We don't understand many of the greenhouse processes, and that's where we wanted to learn from the farmers or from the growers, but also learn from other partners or work with other partners that actually can bring specific applications to it. And so we kind of started developing a rover, a base basically, that has some very specific tangible benefits to it that we kind of thought from the very beginning. Or more or less, we actually developed them while we were at the early stages in the greenhouse. So our robot base had to be omnidirectional. So that means we know a greenhouse is sometimes tight in space. So how can this rover actually maneuver in the greenhouse very agile and not having to, need much space to drive around or have different arcs to enter into an aisle, into a growing aisle also. It had to go seamlessly, driving both on the pipe rail. We saw a picture just a little while ago there from Innovation about how the rails are looking like in the greenhouse. And you see some of them here in the background as well. So getting onto the pipe rail, but also driving on the concrete. So it had to be seamless. It had to be no adjustment there. It had to find itself onto that. It had to be a solid base. We do think we have to carry somewhere in the neighborhood of up to 200 kilogram. We're thinking of, for example, stringing, for example, harvesting, where there's going to be robots, arms, for example. So we want to make sure we're building something that actually is solid and strong enough to handle these applications. Of course, it had to house its own batteries, its own controls. So all these things have to be built into the system. And then what we have not yet fully developed, we're just in the stage right now of testing that out, to actually have an active suspension on the rover. The thinking here behind is that which I will show you in a second, our mast is going up to 5 meters high, and we need to make sure that that rover is always stable at all times. Currently, we're only using it on pipe rails, so it's not a big issue. But if you're going to go in the future onto a dirt road, a dirt track, basically in an aisle, then we think we need to make sure that the rover actually can stay level and not tip over, for example. Here are a few pictures of the rover, how it's actually been running. So the first one here that I'm showing here on the left-hand side is basically, if it's starting up, there it is. So it's being shown how it drives sideways. and then it's rotating pretty much on the spot. So it doesn't have any curve radius to drive. So it pretty much is easily maneuverable. And then it can end onto the pipe rail, still going sideways, trying to align to the pipe rail. And then it goes forward and just enters into it. And you see it was not fully aligned to it 100%, but it was good enough it would find itself on. So we have some allowance in there that actually would allow the rover to always find on the, well, within limits, obviously. And here you show a little bit of the video, how it's actually running while it's coming back to the front of the aisle after it's completed the task. I'll show you a little bit more later on, but this is basically return speed when it comes back and after it's finished the aisle for this specific task that it was doing it. So here's another quick picture of the speed. It actually can go even sideways. It's kind of nice. So it kind of moves quite fast in side speed. I hope that your video is actually that it came across well, but yeah, that's kind of how it's seemed to be acting. Now we have a tooling mast. Like I said, we want to make sure we can support any kind of applications in the greenhouse that go up to 15 feet high. But also collapses down to 7 feet, because we have, at least in some growers, they have, of course, infrastructure built in at the beginning of the aisles, and you need to make sure you fit underneath to get onto the rails. So we want to make sure that there's actually, we can collapse to 7 feet, but then extend all the way up to 15 feet to tend to the plants in that height. The mast, of course, also has to be very strong. It has to have a lifting capacity of, we're thinking around 100, maybe 150 kilograms in that neighborhood. And then what we want to pay attention to, because we know when everything grows in a greenhouse very tightly, it can get very narrow. We want to make sure that the main cabling and all the wiring is actually in the inside. So it was a challenge to actually combine a compact design, but yet have enough space where you can get all the wiring through the center of the mast and actually keep it all safe, because otherwise we were afraid that certain plants may rip it off, or there may be some issues with that. So we paid a lot of attention to those things and trying to develop this. I'm showing you here a little bit of a video of how it actually raises the mast. So you can actually, on the HMI, you can tell it how high you want it to go, to what level, and then it will just raise up to that level and then stop, basically. It can, like I said, this is only going half high right now at the moment, but it will go up to 5 meters, 15 feet, 5 meters. And this is kind of the tooling mount. So we actually also thought about thinking about different applications down the road, not unlike Adapter, what we've done in the past, where we didn't really know exactly what the actual final application always will be. We want to keep it open enough that it could be usable. We thought about the tooling mount. So it has to be applicable to many different applications. It had to have a full tooling face, not just a specific tooling point, because then I have more options to mount it on. I can mount different toolings on here. In this case, here in this picture, you're actually seeing a scouting operation. And this scouting operation actually is actually on a specific slide to actually go even higher than the 15 feet. So it goes actually to 17 feet high, just because we need some additional height on there. But the reason here, there was a specific reason we wanted to be over top the plants for scouting. And but this one, so you can mount a whole slide on there, you can mount certain points on there, but they're customizable. And you have different tooling options that can fit on them. So basically what we're thinking of, there are, of course, many different applications. And right now, at the moment, we are testing out a scouting application that is actually actively being done in the greenhouse right now. We're developing this right now with a partner company, because, again, we don't really think that we want to be the specialists for everything. But we want to be handling robotics platform, maybe something like yield evaluation, but even there, we're open to working with other companies. The picking we want to get to logistics and getting the produce from the picking to the greenhouse, to the packaging area, and things like leafing, deleafing, and so on. So any kind of a handling and robotic applications we probably want to handle or we want to be involved in. What we, of course, looking very much for partners is things like scouting, pollination, stringing, like with innovation, we'll be talking about, like Dennis mentioned it before, that we will be meeting tomorrow, for example. We want to see how can we work together on this application, target disease management and so on. But also on the other side, actually, on Brian Hendel's side with IPM to actually find out how can we, because we don't really want to do all the data logging and all the other side of it. We think there's much better way to work together on these sites. So all these discussions have been happening, and we're trying to be part of an infrastructure of a whole environment that we can all be contributing and all be very strong in. And I think you want to keep it short today, not to make it too extensive. I think we're also running out of time. So therefore, I'm concluding my presentation here, and I'm open to any questions that you may have.
Yeah, thank you, Conrad. Definitely an excellent, robust platform developed for the agri sector. Leslie kind of suggested a collaboration, which is excellent to hear. You're both partners and working with IRAP. Thank you again. I do have a couple of questions for you. As you're developing a platform, have you or are you planning to develop an API or application programming interface so that integrators can use your platform?
Absolutely, yeah, for sure. We just a little bit early right now in the stage. We're trying to develop, make sure we get up our robotics side of it going. But yes, we will definitely have to develop that as we just having discussions with Leslie and with Brian and so on to kind of get more into the details. We have to find out how do we develop these next APIs to connect to those systems. Yeah.
Okay, thank you for the answer. Aaron, anything on your end?
Yeah, I think this is some really great technology, and clearly some strides have been made in terms of the benefit on farm. In terms of the ability of what it could do at farm on the activity side, do you think that it could get to the point where it could do trimmings and pruning of plants as the plant is growing to further reduce the labor requirements on that side of the crop maintenance?
Yeah, like I said, I mean, I definitely think that's where we want to go towards. We do have a lot of different applications in mind, but we don't want to overstretch ourselves or kind of reaching out too far. So we right now, we want to get the platform working thoroughly, and we're working right now on the scouting side. That will allow us to develop the platform, although it's running pretty well right now at the moment. But then, and as we do this now we're looking for applications, and we're hoping even today maybe somebody will come forward and say, hey, I really would like you to look into this application. I really think our biggest need is in this application. So these would be applications that will be mostly driven by the growers and tell us what do they actually need. We want to have a certain base system that we have started with, but then to develop each application, we want to make sure that there's enough interest and opportunities in there to actually start developing those. And then if we do them ourselves or do them with a partner, that still has to be determined. For example, on the stringing, we would be working with a partner. We don't want to do this ourselves. And we always said that from the very beginning. Something like a de-leafing, we would tend towards doing it ourselves. But right now we're trying to assess and evaluate how much of a need is there and who actually wants to step forward and say, yeah, I would really use this if it was available, for example. So
I think we are running out of time, but I do want to ask one more question that came from Brian. Do you foresee autonomy, or currently it's only manual operation? What's the plan for that?
Yeah, so very good question, actually. I should have got a little bit more deeper into this. So the system right now at the moment is you currently at this very moment, you bring it to the aisle and then it goes autonomous, whatever task you give it to do. So it goes all the 100 meters down the growing aisle and comes back again and says, I'm finished. However, in the next, we've estimated about 6 to 8 weeks, we will be having a semi-autonomous operation where it can go from aisle to aisle. You're going to tell it, you're going to be in aisle whatever, 531, and I want you to go to the right for the next 20 aisles, for example. So it will do that. And then as a third stage, that will probably still be another year away until we actually have full autonomy where we can say, go to aisle whatever, do your task and come back home, basically. That's not, but we found when we talked to growers, there was not the biggest need right now, because once they know that the rover can do these next 10 or 15 or 20 hours, that's good enough.
Yeah. So thank you for that answer. Aaron, unless you have any other questions, I think Marion will give you the podium.
No, just I want to say thank you to everybody who attended and certainly to our presenters.
Thank you.
Thank you, everybody.
Well, thank you. This sure took us on quite an information journey, everyone. And a big thank you to our 3 presenting companies for such an informative and resourceful session. There's so many helpful examples here, from how to or don't do, or did you think about this? There's some interesting and scary trends too. It's an amazing awareness of change that's coming down the pipe, how to adapt, how to innovate, and where to find really good solutions. So I mean, this is really real emerging technologies at work that saves both time and money. So thank you, Brian, Leslie and team, and Conrad. You are indeed points of pride for our region. Everyone feel free to reach out to the presenting companies. And a big thank you to Aaron and Nick for all of your assistance with the webinar and with keeping us on track and on time. As we conclude, I just want to put out an FYI. Economic Development Week is next week, and as part of our Economic Development Week activities with Invest Windsor-Essex, we're conducting a business survey of our local businesses of all shapes and sizes. And the survey is going to be opening Monday until the beginning of June. All of today's registrants will receive an email on Monday with a link to the survey. So we're really asking and encouraging everyone to take a few minutes to complete the survey and help us help you, because this data from the survey is going to be very important. And so now that concludes today's events. Thank you to all of you, our audience, for your participation. And please watch for the next installment in this Emerging Technology Speaker Series. Enjoy the rest of your day.
Thank you.
Thank you.
Thanks, Marion.
Thank you.